I'm going to jump in. We'll give everybody an introduction to Snowflake and talk a little bit about our unique value proposition and, for changing the face of data warehousing today. I will jump in and give you guys a quick demo about how, loading some data and just, show you what that is in Snowflake, and then try to save the questions to the end. But if there are any that I get that come into the chat, I will answer those as when Ron takes over as well. So, again, yes. Thanks, everybody, for dialing in. So I'll give everybody an introduction to Snowflake. Jason Miranda here. If you have any questions afterwards, my email address is down there at the bottom, or you can reach out to either the KPI team or find me on LinkedIn or wherever you would like. Then I will get back to you if you have any follow-ups for that. So Snowflake's vision at the beginning of this was just to allow everybody to become a data-driven company, right? That sounds very simple, and that's something that a lot of customers are striving for. But we're doing that a fairly unique solution here, right? We've built the next generation data warehouse that's been built upon the cloud technologies, that are in the marketplace today. The unique thing about this, it is just a SQL data warehouse, right? It's the standard ANSI 99 relational SQL data warehouse, right? So at its core, that's what we are. We're not a Dremel-based tool. We're not something that's been built on a rebranded version of Excel or something like that. We are a brand new relational data warehouse, and we're delivered as a service. So we tell customers, all you have to do is load data and run queries. Snowflake does everything else for you. There's no partitions to maintain, indices to generate, vacuuming, rebalancing of data, any of that. We handle all of that for our customers. So I'll put up some fun facts here and a little bit of information, but we were founded in 2002 by two veterans that came from Oracle. These gentlemen were instrumental in writing Oracle Exadata and Oracle RAC. To date, we have received over $850 million in venture capital funding, which is fantastic for us because that gives us the ability to work in isolation and not have to worry about things like outside pressures from other companies. And we had our customers in 2014, and we were generally available in 2015. And today we have over 1,200 employees and 2,000 active customers. So that means customers that are on a daily, weekly basis, running queries, getting information out of the data that they have within Snowflake. That's not even counting customers that have signed up for trials and things like that. We're talking about customers that are, using the system and paying for those resources. So a couple of fun facts. So we do 100+ million queries a day inside of Snowflake. That's a pretty outstanding number. The largest single table when this slide was built was 68 trillion rows. The largest number of tables in a single database is 200,000. And then we've got customers that have more than 40 petabytes of compressed data. So, that's a pretty large number. That compression can be anywhere from, 5 to 10x. So now we're talking about, 200 to 400 petabytes of data uncompressed. And then we also have a customer that has more than 10,000 active Tableau users that are banging against the system all the time. And more than 4,500 of those are concurrent. Right? So we can scale out to meet that concurrency that any concurrency that you would like. So why would you get Snowflake? So the traditional architectures have been built around a very complex infrastructure, right? Traditionally, you're either on a shared disk or shared nothing architecture. You're constantly in this rebalancing effort where I need to add it. I have additional data that comes in, but now I need to add additional compute to that. I can't be elastic for when I have things like, Cyber Monday or Black Friday come around. The cost model is very rigid in those. You're either paying on-premise licenses or you're paying for cloud compute when you don't need it. And then finally, you have most customers have a fairly diverse set of data. It's not just relational or what we consider traditional structured data that they would like to look at. They also want to look at semi-structured data coming from the website, coming from IoT devices, JSON data, Avro data, Parquet, XML files, all of those sorts of things. And they might not want to land that in the traditional warehouse because, again, compute is tied to storage. And when you increase that storage requirement, you have to add more CPUs, and that can be costly. So how does Snowflake make this easier? It's very simple. So what we have is considered what we call a multi-clustered shared data architecture. That's a mouthful, but the difference between that and the traditional architectures of either the on-premise or the legacy cloud vendors is that they are either what they consider shared disk. That's the Oracles and the SQL servers of the world, or they are a shared nothing architecture, which is the Teradatas and the NetEases of the world. Each of them have their own sets of problems and challenges.
Right? There's always they heard Michael hinder that.
Somebody's not on mute. If you mute off, I'd appreciate that. So each of those has their own sets of challenges. With Snowflake, that compute completely isolated from the data storage, allowing you to have unlimited amounts of either, and you can scale those clusters out horizontally for the amount of concurrency that you'd like, and you scale them up for the speed limit that you'd like to run queries in. It's very, very, very simple in that area. So in terms of how it works, just in terms of a bit of a architecture slide about it, we do what you call workload isolation. And the traditional architectures, everything in that shared architecture, you either have a leader node that is responsible for delegating out authority, or delegating out jobs, and that leader node soon becomes bogged down. Or in the shared disk architecture, you end up running into resource contention for doing things like ETL at the same time that you're running your BI queries. In Snowflake, that's not like that. We do workload isolation for those, so that means that you can have ETL running at the same time that you've got your BI queries running, at the same time that you've got data science running large, data science jobs, and then if all is well, you can actually spin up a test or development environment based off of a zero-copy clone of your production data, run a full test or development or Q&A scale out, all while not impacting what's going on with production and not duplicating data and having resource contention across those. All right, so the idea with Snowflake is workload isolation built upon a shared data architecture. That shared data is always encrypted. You don't have an option to not encrypt something. And then we allow you to do things also like monetize your data. So you can bring the data, share it externally with other consumers of that data. So if you wanted to start monetizing marketing data, geospatial information, any sort of data that you can start reselling to the market, you can do that through Snowflake. And then if they are a Snowflake customer as well, you never have to worry about doing things like putting up FTP sites, ETL jobs to get them out to them. They just query the data in place of where it is. Right? That's a fantastic value proposition for our customers. So just one more note about these gears that you see around here. So these are what we call our virtual warehouses. These virtual warehouses are the compute layer. The compute layer is responsible for processing the queries as they come in. Those queries come in through our global services layer. That global services layer is the metadata about the environment. Right? It's the transaction control, it's the query optimizer, it's authentication and authorization, it's where the query planning happens. So that global services layer runs on its own set of compute, completely isolated again from the workloads that customers are going to be working on. This global services layer again is controlled and managed by Snowflake. That's not something that they are paying for compute on. All customers pay for when they run Snowflake is the amount of time, amount of seconds that compute is running, and how much data storage they have. So the data storage is passed through billing. So for our U.S. customers that are on Azure or AWS. That's passed through, and it's $23 a compressed terabyte. Google Cloud Platform a little bit later this year, but you will then pay for this compute independently of each other. And then lastly, we also have a utility called Snowflake, which allows for continuous ingestion of data, and that leverages some of the cloud-native platform services, so things like Kinesis and Lambda functions to load data into S3, and we will automatically ingest those data files after they show up inside of a bucket, and the same thing for Azure. When they show up in the bucket, we will auto-ingest them in. And a great example of that is auto-ingesting in files that are coming from like a website or from an IoT device, which is typically your structured and semi-structured data for that. You know, traditionally, customers have been building data lakes to analyze that information. In Snowflake, we automatically ingest that data in and allow you to run standard ANSI 99 SQL queries on top of that semi-structured data. That's a very powerful feature that a vast majority of our customers will use for their first set of projects, right? They don't want to load that data to the warehouse because that would, you know, the volume of it would exponentially increase the warehouse and increase their licenses that they're paying. In Snowflake, that's separated, and so you're allowed to bring that data in right away. So the last thing, one last thing I'll say about the compute, and then we'll jump into get close to the demo here. So this compute is, like I said, it's isolated from each other. It can be independently scaled up. So if you want queries to run faster, you would essentially increase the speed limit, which is increasing the size of that compute. And that compute cluster has linear scalability. So if you want a query that runs in 1 minute to run in 30 seconds, you just double the size, or you go up to the next size up, which doubles the amount of compute power in our compute sizing. And then if you need extreme concurrency, you add additional lanes of traffic to that dynamically. So actually Snowflake will do it for you if you would prefer. We will scale that environment out, add those additional traffic lanes as they're needed, and if they're not needed, we will shut them off all the way until they're not needed at all, where we will turn them all off and you stop paying for that compute. So it's a fantastic value proposition for our customers. So what most of our customers have is a landscape that looks something like this, right? They have an EDW, maybe that's an Oracle or a Teradata or a Netezza box or possibly even something like Redshift. They've got data marts that have typically been built off of that because they have a lot of concurrency, and they've got issues where they can't run ETL and the BI queries at the same time. So these data marts are typically built for lines of business that need a subsection of that data but need to be able to have their own SLAs on that. Where Snowflake comes in is it replaces those EDW components. It alleviates the need for having data marts, since the separation of compute and storage allows you to have separate SLAs for each individual department. A lot of customers have moved away from doing the traditional ETL into more of an ELT approach and doing that processing with standard SQL inside of Snowflake. And it also replaces a lot of the data lake infrastructure for analyzing that semi-structured data like JSON and Parquet files and things like that. So this is where Snowflake would fit into your architecture. Obviously, you could start with just an individual data mart and then progress towards moving other workloads off. But this is, where we see customers fitting in here. So, like I said before, we're proven by over 2,000 active customers today. Those are the people that are in, running queries and getting information from their data. Some of the largest retailers in the country, in the world, all the way down to, startups that, don't have any infrastructure and need to get going rather quickly, and want to do that through what we consider a data warehouse as a service. So, any questions there while I jump over to I'm going to jump over to our web UI and load some data for everybody.
Jason, this is Chandru. I don't see any questions in the chat window yet, so please go on to the demo. Thank you.
Okay, sounds great. All right, so I'm logged into my web UI. So I'll give everybody a little bit of a tour around. Normally I would spend a little bit more time doing that. But we'll give everybody a quick tour, just introduce you to what we're going to look at, and then go load some data and show you how cost-effective and how efficient we are at that. So in terms of the web-based UI, you can see we have kind of the standard things that you'd expect out of a database, right? Databases, which you would see down below. I've got, within that database, I've got tables. And within those, I can click on an individual table. I can see some of the details about what's in there, the amount of data and the amount of rows. And so when I click on the individual table, again, just data definition type stuff, right? Metadata. I've got column names, data types, is it nullable? Pretty straightforward, set of information. Of course, we've got database views, both materialized views and opaque views as well. Obviously, there's schemas that go along with this. And then there's also one thing that's a little bit different when we start talking about a web-based data warehouse is we've got this concept of a stage. And a stage is where, for my instance, where I'm going to be loading my data from. So for me, you can use, for other customers, we'll just use an ETL tool or load directly in Snowflake. For my use case, I'm actually connecting out to one of my stages. So if I'm connecting, in particular here, I'm connecting out to Amazon. So I can connect out to Amazon. I would put my S3 URL in here, my security key, and away we go. Right? Pretty straightforward way to connect out to that stage. And this is, again, if you think about an ETL job, this is just a staging area where we're going to load data. Once you've got data in the staging area, you have to tell it what file format you want to load that data in. And you can see that we support a number of different data types for that. So CSVs, and then what we consider the semi-structured data as well. JSON, Avro, or Parquet, all of those are different options, and each of those will have different parameters that you can control. So you can see with CSV, you can skip header lines, what your fields are optionally controlled by, escape characters, things like that. And then if I change that around to a JSON file per se, I've got the ability to strip out arrays and things like that, and for each one of those as well. So once you set up a stage, you tell it the data type that we're going to load. So you saw in my instance, I'm connecting to S3. I've told it that I'm going to load a CSV data type in with this. And then we can start actually loading data once we have compute that we can use. So that compute is pretty cool. So these are those gears, right, that are around that architecture slide. I can give that compute a name, and I can pick a size. So just like I said before, that the sizes are available in T-shirt sizes, and they double in compute every time you go up. So you can see extra small, small, medium, large. We'll start with a medium here to start doing some processing, and if you want to learn more about those, you can click on this link right here and get an overview of the warehouse sizing as well. And the great thing about this actually has your credits per second, which we'll talk a bit about in a little while. So the next portion below that is the clustering. So the clustering is the number of lanes of traffic that you can add to the highway during rush hour. So I can say I want to start with a minimum of 1, where I could bump that minimum higher, go out to a maximum of 10. And if we need additional users for that, that would, again, just be additional compute for them. We would just create another virtual warehouse. We have what we call a scaling policy, which tells you how quickly do you want to add lanes of traffic in there. The first one is considering what you would consider the standard, which would be we predict that there's going to be queuing, so we will add a cluster, make it instantly available, or economy, which is wait till there's queuing until you turn it on. It's your choice. It might be slightly more economical to use the economy method. And then finally, we've got the ability to suspend the compute after it's not being used. And the reason that suspending compute is that you're billed per second after the first minute. So that sounds a little strange, but the great thing about that is that in your traditional environment, you are paying for compute for a large majority of the day where it's not being used. Snowflake allows you to turn that compute off, stop paying for it, and have a very economical model when it comes to that. So I can auto-suspend after 5 minutes. I can even go lower than that if I want to. And then obviously we want to auto-resume. So when somebody comes in and issues a query, I could either uncheck that or check that box so that they wouldn't get a warning that there's no compute available for them. And then the great thing about this is this is all available via standard SQL. So I can put this into an ETL job, data warehouse, fill it up, scale it out, stop it. And the great thing about it is when you do that, you stop paying for that compute when you're done. So we'll go ahead and click on Finish here. So you can see that compute is instantly available. It's started for me. So let's jump over to my worksheet here real quick. I'm going to set my context, and then I'm going to run some queries. Right? So I'm going to start these, and then I'll explain what we are doing with those. So I'm going to run these queries right now. I'll kick those off. And I'll open up the query history, and I'll give you some explanation of what we're going to do. Okay. So remember when we looked at the database originally, we looked at the tables, and then we looked at the stage that we were going to connect out to. Right? What I'm doing is loading some data in. So I'm copying, which is our bulk insert, into the nations table, which you see there on the left-hand side, from my sales stage that we defined earlier, that you saw that was defined, from the nation directory within that bucket, and then we remember that file format we told it was CSV. So I'm going to do that for 6 tables here. I'm going to adjust that warehouse that you saw me create up to a large. So again, I doubled the size of the compute. I'm going to load data in for that one, for another table. I'm going to adjust it again. I'm going to load some more data, and then I'm going to suspend it. So the cool thing about this is you can see this is already happening below, right? So it's kind of flying through loading that data in. If we want to get a little bit more granular details on that, you can see right down here is that first copy command, that first bulk copy command. The important thing here to understand is we started that at 12:23 and 8 seconds. We loaded close to more than 100 million records in here, and that happened in 46 seconds to get that data loaded in. I adjusted the size up, loaded some more data, and then in 18 seconds, so we're getting pretty good throughput on those, right? That 150 million records divided by 20 million, which rounded up to 20 seconds for that one. You're looking at 7.5 million rows a second. And then you can see when we turn my auto refresh on here, when the job's complete, I'm adjusting that size of the warehouse up. I loaded 600 million records in 37.5 seconds. I shut that warehouse off, and now I stopped paying for it. So what's really cool about that is I could actually price that out. Right, so on that first ETL job, we said we kicked it off at 12:23. Oh wait, I said we adjusted the size up on that. So we said that was 46 seconds to get that data loaded in. Right, we'll round the next one up to 19 seconds, where we loaded that second one, and that last one we rounded up to 38. So we loaded close to 1 billion rows of data. It took. Originally, we started at 12:23:08. We finished at 12:24:51. So we're talking about a minute and 43 seconds, and it cost us $1.04 to load that data. You can actually understand and cost out what your job, what your analytics queries are going to be, because you have that detail of billing that you can get back to customers or get back to your business users. Right? So it's, again, very powerful to understand just what that does for you. It reduces the friction to get information into your customer's hands. You see the linear-like scalability, through those, so that performance to load that data, and be able to do it in an ANSI SQL database. So That's really a very, very quick demo for, for Snowflake. We can obviously go back and do some analytics style queries with standard ANSI 99 SQL if you would like. But I would like to see if there's any questions, and then if not, I will pass it over to Ron.
Jason, there are a couple of questions in the chat window. In the interest of time,
I will in the chat, and we can pass it over to him. How's that sound?
Yeah, we'll do.
Okay.
And obviously, when we have time at the end of Ron's presentation, I will bring those questions up to you. I have a couple of questions for you in the chat window. All right?
Perfect. Okay.
Okay. Thanks very much, Jason. That was a very impressive presentation and demo. At this point in time, I would request Ron Cruz from KPI Partners to jump in with his presentation and demo. Ron, over to you. Thank you.
Well, Ron, if you're on mute, we can't hear you.
High-tech manufacturing, retail. We have offices all over the United States and also presence in India as well. The achievements for us is we've won several partner awards, right? Some from Tableau, some from NetSuite. Partner was one of the top BI firms back in 2015. Essentially what we try to do is take all that technology, all that loading of those billions of rows, and make sense of it easily for a business. So we're an experienced analytics partner, right? So we have over 300 consultants, over 200 customers, and over 450 projects have been delivered successfully. We see that number, that's obviously the number of customers. We're doing a lot of repeat business, so people bring us in and they ask us to come back. As you can see from that NASCAR deck, we have a lot of different industries that we deal with. So let's get to the crux of it, right? So you have all this great net new technology that you can monitor your BI, you can monitor your data warehouse, data lake, and all that stuff. But you still have a lot of different challenges. These are, you have a lot of different multiple data systems, have a lot of data complexities, data integration challenges, right? So you might have some data in JSON files or something coming up on a chapter stream. You want to tie that to your data warehouse or some dimensional model or your normalized model. You have customers out there that demand 360 views of their entire data with one simple button click. Right? They're not wanting to wait or run subqueries or build views that dump. They want it all relatively quickly. In order to serve them, you need to have an agile database, right, which is where Snowflake comes in. But you also have to be able to process that and apply the right analytics on top of it. And then lastly, you can't have the Wild West. You can't go back to where we were from the early 90s, where it was everybody was doing everything that they wanted. You have to outline data governance, simplify security, make sure that people can only see what they're supposed to. So what we just talked about at KPI Partners is we have technology and we want to turn it into an application, right? So you have Snowflake and we want to be able to take that and we want to be able to give our customers, a way to use an application in it, right? So what you have to do that, right? So you have this blazingly fast data platform. So how do you get value to your customers? Right? Well, first you got to think about key metrics, what are they looking for, what they want to measure, how they want to measure it. So then after you get all that, you have to worry about data extraction, right? How are you going to get the data in? How are you going to ingest it? You have to worry about data modeling, right? Well, does this make sense in a star, large fact tables, the data lake kind of thing. And then on top of that, you have to put in stuff like best practices, just to make sure that you're not overpaying, that you're getting the throughput that you need to, really leverage that platform as best you can. And then lastly, you have to put in data governance to make sure that people can see what they're supposed to see. At the end of that, you get your application. So this is the log data architecture. This is what, something similar to what Jason was showing earlier, where you have your structured data sources and modern data sources, your IoT, your big data. All that comes through to data ingestion, which goes through Snowflake. And they have different types of processing, batch, real-time, machine learning. And then you have to visualize it, and you have to have your Snowflake out there as well to serve up all your, needs, your business users, your data analytics, and even, do events, like automated events before you your Snowflake. Where KPI partners comes in with KPI Cloud Analytics is we have pre-built content on here, right? So we have pre-built data source connectors, right, that can get data from Oracle, SAP, Salesforce, Workday, Marketing Ontario, so on and so forth. And then we have prepared ingestion jobs. So we have pre-built start schemas, data models, right? Certain data allows themselves, gives themselves well to start schemas. Others need to, require more of a ML model. Some requires reporting tables. We take a look at that and build the right kind of data model for the right kind of use. And then the last part of it is we have pre-built visualizations that serve both verticals and lines of business, right? So you can say, if you're a retail company, you say, I want retail analytics. We have retail analytics that can track your traffic and your, cart abandonment and all that stuff. Or if you're any business and you want to be able to apply your HR analytics to your, hand that out to your HR team or do your financials there. That's what KPI does. It gives you these pre-built content to cut down on your time, cut down on your risk, cut down on your costs, and let you leverage that great Snowflake technology quicker and cheaper. So what comes in it? As I mentioned, right, we have pre-built ETL, right, pre-built data extraction, data ingestion, right, we have built-in change capture mechanisms so that, you don't have to invent the wheel to figure that out for yourself. We have pre-built data models that's optimized for Snowflake on AWS and Azure, right? We do dimensional data models as well as denormalized models, and they can be extended or to be, across various data sources. We have pre-built data dashboards that come from people that work in lines of business and understand the language that your users will use. We have accountants that help us build the financial analytics form. We have HR experts that help us build and architect the HR dashboard and so on and so forth. And again, all of those are customizable because we realize that every client is a little bit different and get more value out of certain dashboards than others. And then lastly, we have pre-built security and governance so that you can limit the data to what people should be able to see. So this is just a smattering, right, to sort of show you what you look at under certain packages. Again, these are, things that we provide people to help them get a leg up on implementing Snowflake and getting up their reporting. Right, this is just a smattering of some of these, right? So you see opportunity to spend, or manufacturing analytics, or project analytics. We have more than this. This is just an example of, hey, how many views are you getting? How many metrics are you running across? How many dashboards, how many reports do you get from each module? So at this point, we're going to go to a demo. And what we're going to do here is we're going to split it in three ways. Well, first, I'm going to hand off to Prashant, who sets up our product development. He will show you backend for Snowflake, some of the stuff that we've built there. And then he'll pass it back to me, and I'll go over really quickly finance. We'll go over some general ledger reports, some accounts payable, and then to sort of show you the rest of the KPI analytics. I'll do some HR, and we'll talk about the hire to retire cycle. So Prashant, I'll go ahead and give you stop sharing, so you can go ahead and
share my screen. Let me know if you can see my screen.
Yes, Prashant.
Okay. Thank you. A very good morning to everyone, and good evening to folks who are connecting from India. So this is Prashant. So I am part of the product development team that works on the KPI Cloud Analytics. So as Ron was explaining to you about what the solution offers, as a pre-built ETL, pre-built data framework, and pre-built models and dashboards, I'm here to talk specifically about our data framework. And when I say data framework, we are basically talking about the entire data infrastructure layer, which talks about extracting the data from all of these different data sources, feeding them into the Snowflake, ingesting them to Snowflake, and then loading them into your governed data model. At the same time, also taking care of handling multiple data sources, handling incremental data strategies, handling restartability. So all of these features are very important when you are building an enterprise scale resilient data framework. And we have chosen actually Airflow as our orchestration layer, which kind of puts all of these things together. And Airflow, for folks who are new to it, is basically one of the most commonly used scheduling and very major companies with a lot of data ingestion needs like Airbnb and all these companies actually use Airflow for their internal usage. So what Airflow gives us is basically a neat UI which allows us to manage all of these different workflows, different processes, different jobs, schedule them, rerun them on failure, and kind of maintain a history of all of those, executions in the past. And what we're looking at right now is the Airflow's landing page. These tags are basically directed to graphs or workflows, which allow you to create them, allow you to create all these different ETL jobs, create the dependencies among all those different jobs, and load the data into Snowflake. And as Jason was alluding to the earlier part, and you all have seen the power and capability of Snowflake. It's indeed an impressive database on the cloud. And with such a system, you have to leverage the best features of it. And we are basically following the ELT approach, which means we ingest the data to the Snowflake, and all of the heavy lifting is actually done by the Snowflake software layers, so the virtual warehouses. Now, let me quickly walk you through one of our DAG workflows. So what we have here is one of our GL modules. So this is an offering from our financial cloud analytics, solution. And this is just one small subset of general ledgers for EBS source systems that we have. And as you can see, what this DAG really does is kind of orchestrate all of these jobs, creating the dependencies across all these dimensions. And what I'm showing you here is more of in a dimensional model with the facts and dimensions, and Snowflake is very good in handling these data models. And we are able to create the dependencies, we are able to create checkpoints, and let me walk you through this point because the load attributes basically picks up. And this is where the framework comes into play. It kind of carries out a lot of information about creating the batch, creating all of the different parameters for the run, which allows for us to do CDCs and restartability and handle any data failures and stuff. And the data first gets ingested to the S3 layer, and from there we load it into Snowflake. And we have multiple schemas, as Ron was explaining in the slides. So we have the operational data stores or data lake layers, then we have governed analytical layers, as well as we have a reporting structure to denormalize tables. So each of this flow basically takes care of handling, basically kicks off the jobs on the Snowflake. We push down all these transformations to the Snowflake database in an ELT fashion. And on successful completion, we will be able to run the facts, and we can create some alerting mechanisms and stuff. And some of the reasons why we chose this is, it allows you to trace back the details, go back to all your runs, explore trend on which jobs were running at what interval, how frequently they basically complete, assess the failures, and track the changes, or see why the job failed, fix your code, rerun them. So it provides a lot of capability, from an orchestration perspective, and how you can basically, manage, your day-to-day incremental loads. And it also gives you the capability to schedule these jobs at different intervals. And, as Jason was showing you in the earlier part of the demo, we could even create these virtual warehouses on the fly with the help of Airflow. And you don't really have to pay for any compute until unless your ETL jobs are kicked off. And all of this can be handled within these, DAG flows that we have created. And we have thought through all of this process, and all of this is pre-built into these, different aspects where it creates your warehouses, it starts loading the data, and then it suspends it at the end of it. system loads. Now, taking a little bit, sneak peek on the models that we have, as you've seen a little while ago on the Snowflake demo, is our KPIs demo account, and what we have here are different databases. And as you can see, we have all these different tables out here. And what I would like to highlight is the different schemas that we have. We have the analytics schema, the reporting table, we have the operational data, store layers, which kind of helps you for your ad hoc analysis or, more of, creating a data lake on the, Snowflake layer in a relational fashion. So we also have this ETL process schema, which basically covers all of your, metadata layer, metadata, which helps us with the framework, the ETL framework. And we also use the stages. For instance, what we have here is the S3 stage where you get the data in, and we also optimize it to use Parquet format so that you get maximum compression. The framework automatically pulls this data from different sources and then compresses them so that your ETL already Snowflake is pretty fast. You've seen it was able to load 1 billion rows in a few seconds. And in Parquet format, it also helps us move the data from all these on-premise systems and the various systems much more faster, moving them to S3, and then from S3 loading it into Snowflake will be all the more faster. And a quick peek at some of the tables that we have, you see the most database we're looking at. As you can see, we have a whole bunch of tables, apart from the ones that you saw in the DAG workflow. We have AP modules, AR modules, and accounts payable, accounts receivable, and general ledger, and a host of facts and dimensions going ahead with that. So that gives you a quick, sneak peek on what the data model looks like and the orchestration layer looks like. Now I'd like to hand it over back to Ron to show the front end and see what kind of triple dashboards and reports that come from.